going to talk through graphing linear inequalities. So it's a three-step process, and the steps are listed here. I'm going to go through this on the video. An old skill to remember: whenever you multiply or divide by a negative number across an inequality symbol, remember to flip your symbol. So if I have a simple inequality like this, I divide both sides by -3. I have to flip the inequality symbol because I multiply or divide by that negative number across the inequality symbol. First old skill to remember. Now, moving on down, here I'm given a single inequality, and I'm given XY ordered pairs, and I'm asked to determine which ordered pairs are solutions to the inequality. So I'll test the first one, x and y. If I let x become 2, if I let y become 5, ask yourself if that's true or false. That's a true relationship. So that means that this is a solution to the inequality. This is an ordered pair that makes the inequality true. Moving to the next example, if x is -1, if y is -7, then I'm left with +19, less than or equal to, or less than 15. This is a false statement. So that means that this is not a solution to the inequality. That is not an ordered pair that makes that true, and I will let you do the other two on your own without me. Moving on down to actually graphing the lines. It could be easier to make sure that each line is in slope-intercept form. It's not necessary, but it could be easier if that's your preferred method of graphing. And make sure that you flip the inequality symbol if you have to multiply or divide by a negative number. So here, we're going to use a solid line if we're graphing less than or equal to, greater than or equal to. And this means that all points on that line are in the solution set. All points on the line are solutions. So that's what it means to graph with the solid line right here. I'll switch ink color. You're going to use a dashed line when you're graphing the strict inequality. So that means that when you go to the plane and graph, you're going to have holes or broken spots in your line. This means that points on that line are not in the solution set. They are not solutions, not in the solution set. So that's the visual difference as far as determining the solution when you're looking at the solid line versus the broken line, and the strict inequality versus the inequality that has the equal to with it. So I'm going to ask, maybe you need to pause the video, jot this down, and I'm going to move on to actually graphing the first linear inequality. So the first inequality is presented in standard form. So I'm going to isolate the y. I'm going to subtract 2x first. Subtracting 2x does not require flipping the symbol. So I'm going to recopy that. However, when I divide by -3 to isolate the y, this is when I would need to flip that inequality symbol. So now my slope is +2/3 and my y-intercept is -5. So notice what I've done there. I've isolated the y and I had to divide by a -3 in order to make that happen. So now I'm going to graph my line starting at -5. There's my starting point. My slope is +2/3. And here's my line. That's all this graph will hold. I have a strict inequality, so that means that when I graph, I'm going to graph this with a broken line, meaning that points on that red line would not be solutions. Now I need to determine which side of the line I'm going to shade which side of the line will contain all of the ordered pairs that will make the inequality true. 0, 0 is the best testing point if it's clearly on one side of the line or the other. So when I go back to my inequality, if I let y become 0, and if I let x become 0, then I'm comparing this, 0 greater than -5. And I ask myself if that's true or is that false. This is true. 0 is greater than -5. So that means that I've chosen a testing point that makes my inequality true. That means that every point on this side of the line will make that inequality true. So So I shade my solution region. So I now have all of the points that are above the line. This is my solution region. Points below the line are not solutions. Points in the red region, any ordered pair that I choose in the red region would make this inequality true. Points that would be sitting on my broken dashed line are not in the solution set. This is just simply a boundary point telling me that all of the points above this line will make my inequality true. So the way that I present my solution set is by shading the correct side of the line. And let's do one more on the video. Let's just do number 1. It's already given in slope-intercept form. So I'm going to start at -5. And my slope is positive 1/3. And I have a strict inequality again, so I'm going to do a dashed line, not a solid line. 0, 0 sitting right here. If x and y are both 0, then I'm left comparing 0 to -5. Once again, feels like the same problem. This is a true statement. So that means that I'm going to shade above the line. All of the points above the line are solutions to this inequality. The dashed red line, the points that would be on the red line are not in the solution set. It's just simply a boundary point in the plane.